Okay, hello everybody. Today I will present you a project that I made just to demonstrate uh, how to deploy machine learning applications to the cloud. You will see that the metrics is not enough or is far enough to be a good metric, but it will explain how to make the entire pipeline of a machine learning process. So we will start first here. We will predict the, let's say, the age of the abalone. An abalone is like a seashell animal that lives in waters. Usually you have this process that is very boring, that you have to measure the abalone, and then with the rings and other kind of measurement you can predict if the abalone has some age. So practically we download the dataset from UCI machine learning. The first step is to gather the data. So for gathering the data, we use the machine learning repository, and there are two data files. One named abalone.data, and the other one named abalone.names. The abalone.data has all the data set that we need to make the machine learning model, and the .names file has everything related to the dataset. So it explains which features are used, the papers that were before the last one, and the other papers that get the metrics, how they used to do the machine learning model, which metrics work, which model work, and what kind of uh, stochastic method or any kind of machine learning method that they use works. So we first read with the URL lib the data and decode it by lines, because when you read some data sets from the machine learning repository or the UCI, you will have some problems processing the data. Usually you can use pandas, but in this case we cannot use pandas, or at least it's not working for me. So I'm here with that information that I split on rows. Next thing is to divide the data set and make try to make a list of the whole data sets. So when we have the whole list of data sets, we need to put it, or at least I usually do a data frame to put the information. So we have these lists that are like 10 or 9 features. 1 2 3 4 5 6 7 8 9. Okay, are 9 features, and the column names are the names that are listed here. Next, we convert some columns. For example, you will see that uh, after the first column, everything is related to numerical data. So I convert everything to a numeric data set. And this thing is a categorical data. So this column, this name sex, is composed with male, female, and infant. So the Avalon has sex, three kinds of sex in the dataset. We are just keeping the information of the dataset, the minimum and maximum levels that will give us some point to make the Streamlit application. We then get the data types. As you see, I convert everything to integers or floating points, and the first column is still remaining in categorical information. Next, we have some visual insights just to continue with the process. Usually, you have, or you will need to check the information of the dataset, and now you see that there's a and their data set is not practically normally distributed. Usually with imbalanced data, you will try to correct that imbalance and try to remove outliers, but here I'm just demonstrating how the machine learning pipeline works. Next, we'll plot some information. How, for example, I just selected the diameter and the length and make a color map of the Abalone depending of the diameter. So this remains that is less diameter, for example, red, and this remains that is the diameter is long, the longest ones. So this kind of bar graph is just divided in how it's distributed, the sex over the kinds of rings of the Avalon dataset. So we will see that it's practically very well distributed. But on the other kind of information, probably not. So the next thing is to handle missing data. Thank God this dataset has no missing data, so we can pass this thing. But usually when you have missing data, you will try to do imputations. So using the most frequent data, using a machine learning model to input data or remove the rows. So that's part of the machine learning pipeline. Analyze the data, pre-process the data, transform the data. So the next thing is the feature extraction. We first are still looking for the data set. For example, we have near 4.2k elements or instance in the data set. Usually, and here are the minimum and the maximum values and here's the standard deviation of every kind of feature. These 25, 50, and 75% correspond, for example, that 50% of the data set has near zero point 0.5 millimeters of length. That's all that is said. This is a correlation about the data. It's a good idea to see the structure and foresee the correct information of the data set. We usually try to to map this data set in a very common way, like a heat map, something like that. I will do it in a Streamlit application. Next thing is we have a categorical columns. Sorry. We have categorical columns like sex, so we have to make a labeling code. So there are two kinds, or there are several kinds of encoding. One is label encoding. With label encoding, you get, for example, numbers 0, 1, 2, depending of the column, how many kind of labels are. And the other one is one-hot encoding. For example, you will convert the sex to sex m, sex i, and sex f columns here. When each one is present, you will see a one here. For example, if it's let's move forward over an example here. Just think that this array is remaining here in columns. You will see, for example, if the first element of the dataset is male, you will see 1, 0, 0. And for example, for the second line of the dataset is if it is infant, you will see 0, 1, 0, and so on. That's the 100 coding format. I'm using label encoding because it's pretty normal, pretty common to see a label encoder. So you will see, for example, when I label encode, I get this array. I transform the label encoded to the dataset. You will see that we will get numbers, and if we inverse the dataset, we transform from numbers to the correct class. So now you will see that we have popped up from the dataset the rings that will be our targets. In the machine learning model, we will have, in this case, is a regression problem of the supervised learning section. We'll have targets, we'll have features. The features Now you see that are labeled encoded here, and everything is numbered. For feeding things in a machine learning model, we will have, or we must have, everything converted to numbers. And because I have now the targets and the features, I convert each one to a NumPy array for better understanding. The next thing is try to split the dataset, so we'll have a training features or training on and the training target and testing feature and testing targets. And we'll convert these numbers to values within 0 1. Usually there, in this case, there is no need to scale, but probably for the sex column, it will be okay to normalize or standardize. Sorry, standardize. Uh, I'm using standardization. It's a pretty common scaling thing to do in machine learning, and I use several kinds of models here. I will use the support vector machines, or further, the support vector regressor, that is part of the support vector machines. I tested for every kind of situation, for example, RBF, linear, and poly. The one with the best measurements for me were the poly one. For example, you will see that the mean absolute error is like 1.5. It's not too bad and it's not too good also. Uh, let's explore how we did it. You will first import the super vector machine, feed the model for the training and the test set. Sorry, for the training set and the training labels. In the end, when everything is trained or fitted, we'll try to predict the age of the Abalone by the rings. Yeah, we're predicting the rings. These are the predictions. Uh, Next, we will try to use the cross-validation of, we will try to cross-validate over 5 samples, and we get this kind of test score. The score is not as good enough, as you've seen, probably is more or less better than random guessing, but it's what we have. Remember, I'm not focusing on optimization. I'm just focusing on how to make a machine learning model and deploying it to the cloud. Next, we evaluate the mean absolute error of our machine learning model, and we'll get 1.5. The other thing that we selected to test is a random forest regressor. We tested we get a mean absolute error of 1.79, and the same thing with the stochastic gradient descent regressor. We get a mean absolute error of 1.792 and a K-near-X-Nickborn regressor with a mean absolute error of 1.61. So the best model here is this support vector regressor. That's where we will try to test here. We will plot the results of the prediction and the test predictions. That's where we are plotting here. So practically it do a not a very decent job, but it demonstrates the how to do inference and how to plot it and everything. Next thing, we are trying to save a model to the disk drive. So this we are using Pickle, that is a library to serialize the information of the machine learning models. And next, we'll try to predict the important model. I'm importing the super vector, trying to save the super vector machine model. Just to keep it updated, we are trying to load the model again and try to do the predictions of the current model to the previous model to see if they are okay, and if they are okay, it will not give us an error. And just here it's just validating that it's the same model and has the same results. That's not important, actually. So in the end, we are inserting this on the machine learning model, and we will get a target output that is in the number of the rings of the Abalone. The next thing to see is the Streamlit application. Let's see if we can see the Streamlit application. Okay, this one. So here we are using Streamlit. All the libraries that we need is from scikit-learn and pandas, numpy, pickle, and also I mentioned the request for getting the model, everything. So the first thing is to load from, we are using some loading files. We're using Lodi to give up a very decent image. Probably you're not understanding everything. Let's see the Lodi application. Sorry, the Streamlit application. We will open it. Okay, here is what you are seeing. You are seeing here everything related to the predictions, and you are populating the information about the sensor, the correlation metrics. Probably it's better to have this thing populated just only one time, because each time that I try to move here, the system try to make the prediction and recalculating everything related to the dataset. So because I'm doing fixed graphs, it's better to have just the calculation of the information just one time and put it over the Streamlit application. Let's wait. Everything doesn't change because, as I told you, it's the same dataset. It's not very dynamic. For very dynamic approaches, you have to have the information related here related to each one of these things. So for this kind of information provided to our model that is female, have its length, its diameter, height, and the other things of the weight, we will predict that is 14 rings for this Abalone. The other things is just visualization. So here I'm doing this thing. I'm doing Streamlit app. This is very important. If you are using a wide layout, you will have to do to get it at the beginning. Lodi is for importing this image that is here. For example, we can get Lodis from the web and import the Lodis. This is for reloading the model only and getting the cache. And this is where we display the Lodi. This thing here is related to the sidebar only. Everything related to the sidebar. So you call it using Streamlit. You get minimum values, the maximum values, the data set, and insert each value inside the data set. For example, sex, we get male, infant, female, the minimum values of the length, the diameter, the maximum values of the length, the diameter, and so on. And this is the step that we want to follow. So this is the middle page. We'll try to write some information for the user to make it very understandable. This is the information about how to convert the sex box. For example, if it's male, select that is 2, if it's infant, select this 1. That's the thing that we made on the label encoder. Here, we use the label encoder because actually we have to convert the data frame sex column to integer. So that's what we're doing here. We are loading model and converting everything related to the data frame to get predictions, and we put the prediction here. The other columns are just for displaying and plotting. So we get three columns. The first one is related to the relationship of the diameter and the length. That is this graph here. The other one is related to the VNet data here. And this one is related to the dataset structure only. The next one is the middle, the data frames related to the dataset description, the dataset structure here are here, dataset description, dataset structure, and the last one is the correlation matrix. Sorry, the information about how to graph the correlation matrix. Is correlation matrix. How to deploy Streamlit applications? Well, you will first need to have a Streamlit file that's like this one. So you make your Streamlit file, like this one presented here, put on your root folder, not necessarily in the root folder, but it's preferable to have it on the root folder. And also you will need a requirements file. In the requirements file, you put every kind of um, library that you are using to make the Streamlit application. Next thing is to, when you have your repository, you will go to share streamlit.io, and they will try to get you to make a new app from the repo. For example, you specify which repo. Next thing is the branch, if you're using master or something like that, and the file. When you instance the repo, it will connect to the repo and try to uh, understand your repo, which branch but you can enter manually, and also which kind of main file where is. Next thing is to put deploy, and it will deploy the application. And when you start deploying the application, we'll see a black window here installing all the information about your requirement file, and you will end finally with something like that, your application that you can share to your manager or any friend or anyone that you want to say, hey, look what I did on machine learning, some kind of thing that is very funny or it's very useful, just to share your path to the machine learning engineer or data science engineer. It's a pretty way to do uh, things that you can demonstrate to others. So, uh, finalizing things, we will first make the ETL pipeline. ETL comes from extract, transforms, load, and then finally try to make a model of the data that we have to predict the Abalone age by the rings. Next thing, we put everything on GitHub. And the final thing is to deploy the application using Streamlit. It's the best way, it's the easy way. Not the best way, it's one of the easy ways. The other one is not very complicated. It's also easy too. Is using Heroku, and the other one is really using AWS. Probably on the next video, I will try to show you how to deploy the application using Heroku. Currently, or for this demo, I will use only Streamlit. So that's all. Thanks for watching. I apologize because I have a lot of time that I don't upload a video since 2 or 3 months, but it's very demanding job, and also uh, I get the time now because there are holidays to get something very different for you to check if you want to make any kind of machine learning stuff of pipeline to make an application. So that's all, and thanks for watching.